Hey there, class. We're here to look at converting numbers from other numbering systems into the decimal system. So that's our goal here today. Now let me remind you of a couple quick things here when it comes to place values in different systems. In a previous video, I talked kind of in detail about this, but in the decimal system, we're used to thinking in terms of the ones place value, the tens, the 100s, thousands, 10,000s, and so on. Now in other systems, we don't use the base 10, so we're using different bases. So in the binary, it's a base 2, so it's not the ones, tens, hundreds, thousands. It doesn't work that way. We have different place values here. It's the ones place value, the twos, the 4, 8, 16, 32, 64, and 128. So again, because the base is a base 2 system, it's a different place values. Likewise, in the hexadecimal system, because it's base 16, the place values are the 1s, 16s, 256, and 4096s. So that's a little strange at first, but once you start to understand this, it'll make sense. So let's get down here to some fresh screen, and let's talk a little bit about how this all works out. So let's take a look at a number, and the number is 238. Okay, this of course is in the decimal system. And let's take a look at what's really going on here. One way I can think about this is I basically have two 100s. Okay, I have the number 2 in the 100's place value. So that gives me an equivalent amount to 200. I also have 3 in the tens place value. That gives me 30. And I have 8 here in the ones place value. So I have 8 times 1, and that gives me 8. Now if you take a look at adding these together, I have 200, I have 30, and I have 8. This gives me a total of 238. Now this should hopefully be pretty obvious to you, but in our system that we're used to, this should make a lot of sense. I could represent this number with 2 100s, 3 10s, and 1 8, which of course gives me a total of 238, which of course is the number that I'm looking at. Now let's take a look at an example here that involves a binary number. The binary number we have here is 1110, 1110. Now keep in mind, these place values are not the same as if we had a base 10 number. These place values are different. So for the binary number, this place value here, actually let's start at the left. This place value here is the 128th place value. So I have 1 128th. Again, this is the place value here. One of them gives me 128. This next place value over is the 64th place value. So I have 1 64th. And that is going to give me a total of 64. One of them gives me 64 of that. All right, next place value over here is the 32nd place value. So I have 1 32nd. It gives me 32. This place value here is the 16's place value. I don't have any 16's, so 0 times 16 is going to give me 0. Here we have the 8's place value. I have one of them, so 1 times 8 gives me 8. This one gives me, this is the, what is that, the 8's place value, so this is the 4's place value. I have one of them, so that's 4. This place value here is the 2's place value, and I have one of those. So that gives me 2. This place value down here at the very end is the 1's place value, and I have 0 of them. So that gives me 0. Now I have to add these all up. Let me get my calculator out here. Let me put that in the screen here. We can do the math. But basically I'm going to add up numbers right in here in this column to see how much this totals up to be. Bring my calculator back over. Here it is. So let's say 128 plus 64 plus 32 plus 8 plus 4 plus 2 equals 238. 238. So maybe it's a surprise to you, but maybe it's not, that the number that we started with, which was in the base 2, which is a binary number, 1110, 1110, base 2 is actually equivalent to 238 in the base 10, or a decimal number. Let's look at a third example, which is going to be in the hexadecimal. Okay, so here we are. The hexadecimal number that I'd like to take a look at here is the hexadecimal EE base 16. So this, again, we often don't think of it as a number, but this is a number in a different system. Of course, the ciphers being used here are the ciphers E, which E, remember, means 14. Now, a couple things to note here. There is no number written here, or there's no cipher written here and here. So basically, you can think of this as a 0 and a 0. Again, we don't typically write those out there, but we certainly could if we wanted to. But basically, again, just kind of thinking about this, there's 0 in the 4096 place value. So basically, we get 0 there. There's also 0 in the 256 place value. So we're going to get 0 there. This is the 16's place value. And remember, E represents 14. So we have 14 16's. 14 times 16 gives us 224. And this place value here is the 1's place value. And again, an E represents 14. So 14 ones gives us 14. We take these two things, add them together. 4 plus 4 gives us 8. 1 plus 2 gives us 3 and a 2. So this is actually 238. So notice the hexadecimal number EE is actually equivalent to the decimal number 238. So hopefully now you have a better idea of how to convert from a system that's non-decimal into the decimal system. Keeping in mind that each of these numbers, each of these digits, I should say, represent a number of place values. Again, we typically think of it in the decimal system as 8 ones, 3 tens, 2 100s, but in these other systems, it's not the familiar 1, 10, 100, 1,000, so forth and so on. It is a different, you have to think about it differently, these different place values. So understanding these place values that we talked about up here in a previous video is going to be kind of very important.